Hello everyone, so here is the first part of your notes for 1.3. We're going to be talking about the midpoint. Alright, so first we need to go ahead and define what a midpoint is. If it wasn't already obvious from the name, this is a point that is exactly in the middle of a segment. Now, because it is exactly in the middle of a segment, there's a special thing that happens as well. The segment is split into two congruent parts. All right, so let's go ahead and draw a picture of what this looks like. So I will go ahead and first draw in a segment with two endpoints. Let's go ahead and let's call this segment AB. Now, if I have a midpoint on this segment, it needs to go exactly in the middle. So let's go and let's call this point M. And point M is going to be our midpoint. Now, the second part of the description here is that it says that the segment is split into two congruent parts. Well, if point M is in the middle of segment AB, that means that segment AM is going to be congruent to segment AB. So I can mark it on the picture using these congruent tick marks. And then I can also write a statement that says segment AM is congruent to segment MB. Okay, let's go ahead and talk about our second word for the day, which is a segment bisector. Now, this word bisector, there are two roots in here that help us give the meaning. Bi, which means two, and sect, which means to cut. So bisect or bisector means to cut into two congruent parts. In our particular case, because the segment is being bisected, this means that we are cutting into two congruent segments, not just parts. So here is the formal definition. A segment bisector can be a line, a ray, another segment, or a point. That cuts another segment into two congruent parts. So let's demonstrate what this looks like. Let's go ahead and let's draw in another segment. Let's go and let's call this segment JK. And let's have a line that cuts this segment into two congruent parts. I'm going to go ahead and call this line N. And I'm going to go ahead and call the point of intersection between the line and the segment, let's call that point T. So, line N is a segment bisector. And because of that, we know then that JT must be congruent to TK. So let's go and let's write that down. Segment JT is congruent to segment TK. And this is because we have a segment bisector. Now, one last thing to note is that segment bisectors must pass through the midpoint. Because again, the midpoint is the exact middle of the segment. And so if you were to have a segment bisector, which cuts your segment into two congruent parts, it has to pass through the midpoint. All right, so let's go ahead and take a look at how this might work in an example. So in the problem here, it says that segment VW bisects segment XY at point T. And they also tell us that XT is equal to TY, which is equal to 39 and 9/10 of a centimeter. What they would like for us to do is to find the length of segment XY. Okay, so let's go ahead and let's draw a picture to represent this. Looking at the problem, we see this word bisects. And again, just to remind ourselves, this word bisects means to cut into two congruent parts. So I need to make sure that I label those parts in the picture once I draw it in. Now, the segment that is doing the cutting, the segment that is bisecting the other, is VW. So let's go ahead and let's actually draw segment XY, since this is the segment that will get cut. So there's segment XY. Let's see if we can kind of eyeball our midpoint right there, because the segment VW needs to go through that midpoint in order for it to bisect. Segment XY. So here is segment VW. Now, one last thing to label is that this segment VW bisects or cuts segment XY at point T. So at the point where we're doing the cutting, we need to go ahead and label that point T. All right, last but not least, we want to go ahead and we want to add in our congruent marks to remind us as to which parts are congruent, which segment is the one that got bisected. So we have here segment XT is congruent to segment TY. Now, what they want us to find is the entire length of XY. So from X all the way to Y. This is our question mark. This is what we're looking for. They tell us that each of these lengths is 39 and 9.9 centimeters. So let's go ahead and let's use the segment addition postulate to figure out the length of the entire segment. The segment addition postulate says that you take each part of the segment. So XT is one part, and I add it together with TY, which is another part. And this gives me the entire length of the segment XY, the whole segment. Now, all we need to do is substitute in. So I get 39 and 9/10 plus another 39 and 9/10. And this is all going to be equal to the length of XY. All right, and then adding these two numbers together, what we get at the very end of the day is that 79 and 8/10 of a centimeter is equal to the entire length of XY. All right, go ahead and pause the video here and see if you can give this one a try on your own. All right, go ahead and check over your answers. Once more, I went ahead and I reminded myself that the word bisected means to cut into two congruent parts to make sure that I remembered to mark each half or each part of the segment as congruent. And that's what helps me remember or know that if MQ is 2.5 inches, then PM must also be 2.5 inches. And then from there, we write down our segment addition postulate, substitute in, and then we finish solving. All right, now this problem is just a little bit different. Let's go ahead and let's read it first. So point M is the midpoint of segment VW. They want us to find the length of segment VM. So in this particular case, our picture is already given to us. M is the midpoint, and so VM is congruent to MW. Now, this one is a little bit different because we don't necessarily need the entire length of the segment. So we're not going to use the segment addition postulate here. Instead, we are going to use the fact that VM is congruent to MW. In other words, the lengths of these two segments are equal. So that means that I can take the length for VM, which is 4x minus 1, and I can actually set this equal to MW, which is 3x plus 3. Again, this is only possible because I know that these two segments are congruent. From here, we're going to go ahead and we're going to use regular old algebra to finish solving. I notice that I have x's on both sides of the equation, so I'm going to go ahead, I'm going to pick the smaller one to move to the other side. So when we do that, because it's a positive 3x, I'm going to go ahead and subtract 3x on both sides. 4x minus 3x gives me 1x. Minus 1 is equal to. This becomes 0, and I'm just left with a 3. Last but not least, I need to get x by itself. And to do that, I need to get rid of the minus 1 by adding 1 on both sides. We're now left with x. Again, this becomes 0, and this is equal to 4. Now, keep in mind that we are not yet done with the problem. The problem is asking us to find the length of segment VM. What I have found is x, and x here does not represent the segment for VM. So let's go and let's substitute in. What we have from the problem is that VM is equal to 4x minus 1. We know what x is now, so let's go ahead and let's substitute in for x. So we get VM is equal to 4 times 4, because that's what x is, minus 1. Finishing this up, we get that VM is equal to 16 minus 1. And at the end of the day, we find that our length VM is equal to 15. And that right there is our final answer. All right, go ahead and pause the video here and see if you can give this one a try on your own. All right, go ahead and check over your answers. Now, same idea here. The segment bisector, by the way, is going to be line N as it passes through the midpoint of segment RS. And then in order for us to find the entire length of the segment, we can't just add RM and MS together just yet because we run into a problem with these x's. We don't know what they are. So instead, we set the two segments equal or congruent to each other, substitute in, solve for x, and then now that we know what x is, we're going to substitute that in to our segment addition postulate. And then we finish solving and we get that RS is equal to 66. Okay, so now let's go ahead and take a look at the midpoint on a coordinate plane. So here is the XY coordinate plane, and I have two random points. One point is called A, another point is called B. Now, even though I don't know what the coordinates are for A, I can still label them. So A is going to have a coordinate of x1, y1. And then same thing for B, except I already use x1, y1. So for B, I'm going to use x2, y2 instead. Now we can go ahead and we can connect points A and B with a line segment to form segment AB. All right. And the other thing also that we should note is that because this point is at the end of the segment, it's quite literally called an endpoint. Okay, so we have a segment with two endpoints. We also have the midpoint of this segment. We're going to go and we're going to call that M. And the coordinates for that midpoint are going to be xm, ym. Okay, instead of x3, y3, I'm going to say xm, and m stands for midpoint. How we find the actual coordinates, the actual numbers for the coordinates, is we will use these two equations. To find the x-coordinate of your midpoint, this will be equal to x1 plus x2. All of that gets divided by 2. We have a very similar equation for the y-coordinate of the midpoint, so it's going to be ym is equal to y1 plus y2, and all of that also gets divided by 2. But at the end of the day, our final answer needs to be written as a coordinate. So the coordinates for the midpoint, we go ahead and we write it with the parentheses and the comma, and this is where the numbers and values will go. All right, so let's go ahead and let's use that in an example now. So in example A, the endpoints. So here they give us endpoints of segment RS are R1, -3, and S4, 2. They want us to find the coordinates of the midpoint. First thing that we want to note is that they want us to find the coordinates of the midpoint. This will become a little bit more important later on, but for now, let's go ahead and write down xm, ym for the coordinates of the midpoint. We don't know what they are yet, but we will soon solve for them. I have two endpoints given to us, R and S. It doesn't really matter which one you label as which, just go ahead and pick one. So for R, point R, I'm going to label that as x1, y1, and I'm going to label S as x2, y2. Now we have all we need to substitute into our equation from earlier, which said that xm is equal to x1 plus x2, and all of that gets divided by 2. Now we just need to substitute. x1 is 1. And I'm going to go ahead, I'm going to add x2, which is right up here, the x-coordinate for S, x2. So we're replacing x2 with 4. All of this still gets divided by 2. Finishing this up, we get that xm is equal to 5 divided by 2, or as a decimal, we have xm is equal to 2.5. All right, so that takes care of our x-coordinate for the midpoint, but we still have to find the y-coordinate as well, but it's not really any different. To find the y-coordinate, you take y1, you add it together with y2, and all of that gets divided by 2. So the midpoint coordinate for y is going to be equal to y1 is a -3, according to what we labeled right here. And we're going to go ahead and add y2, which is a positive 2. And all of this, again, gets divided by 2. Finishing this up, we get ym is equal to negative 3. Adding positive 2 gives me negative 1 divided by 2, or ym is equal to negative a half. Okay? But again, this is not the way we write our final answer. We need to make sure that we write it as a coordinate. So our midpoint M has the coordinates 2.5 and negative a half. This is our final answer. We can go ahead and we can use the graph to double check our answer. So what we'll do is we will actually physically graph point R and point S. Now, point R is at 1, negative 3. So I start from the origin. I go to the right 1 because it's positive. And then I'm going to count 1, 2, 3 units down because I have a negative 3. And this is where point R will go. I'm going to go ahead and make sure that I label point R as well so I remember which one was point R. And then for point S, again, same thing, starting at the origin. And I'm going to count to the right. 1, 2, 3, 4, because that's my x coordinate. And then up 2 for my y coordinate. And this is where point S will go. Okay. And then we're going to do our best. It's best if you have a ruler on hand. And connect these 2 points with a segment. Okay, so once you have connected the 2 points with a segment, we're now going to go ahead and also plot our midpoint coordinates, which tells us to go to the right 2.5 and down a half unit. So here we go, counting. From the origin, we go to the right 1, 2.5. And then we're also going to go a half unit down. So the exact point is right about there. So my line that I drew in is a little bit off, but it's pretty gosh darn close to where the actual midpoint is. So if I double check and I take a look, just very quickly kind of eyeballing both sides of the segment, they look about to be equal. So that's how I know that the coordinate that I solved for is correct. Go ahead and pause the video here and see if you can give this one a try on your own. All right, go ahead and double check over your answers. Specifically, watch out for when you substituted in the negative number for x2. Make sure that you change this to become subtraction, right? Because I have different signs, addition and subtraction. So that just becomes subtraction. And the numerator here becomes a negative 10 divided by 2. Again, you can use the graph to go ahead and check to make sure that your answer or your coordinates are correct. But you want to make sure that you can actually do all of this work here. Last but not least, write your answer in coordinate form, please. All right, so example B. This one is a little bit different. The midpoint of segment JK is M21. So right off the bat, they give us the midpoint. It is M at 2, 1. One endpoint is J14. Find the coordinates of endpoint K. So this is what I was mentioning earlier. In this particular example, we need to look for an endpoint. We are already given the midpoint. So because we're already given the midpoint, I'm going to go ahead and take this moment to label our midpoint as XM, YM. So those coordinates are already provided to us. One endpoint is J, so let's go ahead and let's call that X1, Y1. And then so the coordinates that we're looking for is going to be X2, y2. The setup is the exact same. So that equation, xm, is equal to x1 plus x2, all of that divided by 2. Let's go ahead and let's substitute in. I do have x1 labeled here. It is 1. Now I need to add x2, but in this problem here, I don't know what x2 is. So we're going to go ahead and leave it alone. This is the variable that we are going to solve for. I'm still, of course, dividing by 2. And here's the thing. This is supposed to be equal to xm, but I know what xm is. Xm is the x-coordinate of your midpoint that we labeled up here. So because it's 2, I'm going to go ahead and substitute in 2 for xm. All right, and then from here, I notice that we are dividing the entire right side by 2. So in order to cancel out this division by 2, I'm going to go ahead and I'm going to multiply both sides by 2. Dividing by 2 and multiplying by 2 cancels out to give me a 1. And then 2 times 2 on the left side is just 4, is equal to 1 plus x2. Finishing up, because again, what we're solving for is x2. That is our unknown. We can subtract 1 on both sides of the equation. 4 minus 1 is 3, is equal to. This number right here becomes 0, and I'm just left with x2. All right, so we went ahead and we found the coordinate for the x-coordinate for the endpoint. We need to go ahead and do the same thing for y. So ym is going to be equal to y1 plus y2. All of that gets divided by 2. All right, substituting in. Again, ym, we know what ym is. We labeled it. It is 1. So I'm going to replace ym with 1. This will be equal to y1, which we labeled as 4, plus y2. We don't know this one, so leave it as it is. Leave it as y2. All of this gets divided by 2. Same step here. We're going to go ahead and we're going to multiply both sides by 2 so that here the denominator becomes 1, and I get 2 times 1 on the left side, which is just 2. This will be equal to 4 plus y2. Last but not least, we're going to go ahead and subtract 4 on both sides of the equation. 2 minus 4 gives me a negative 2, and this is going to be equal to, this becomes a 0 plus y2. And there we go. But again, keep in mind that what we found is the coordinates of the endpoint k. So, finishing up our final answer, instead of saying the midpoint this time, this is our endpoint k, and k has the coordinates 3, -2. Quickly double checking that on our coordinate plane. I'm going to go ahead and I'm going to actually graph the endpoint first. So one of our endpoints is at 1, 4. So to the right 1 and up 1, 2, 3, 4 units. So right over here. This is point J. And then our midpoint M is at 2, 1. So going to the right 2 and then up 1, here is the midpoint, M. Now I can, just like before, join these 2 points with a segment. However, M is our midpoint. It needs to be in the middle of the segment. So what I actually need to do is I need to continue past point M. And once I continue past point M, I want to continue past it about the same amount as JM. So if you recall from slope, from J, we go down 1, 2, 3 units, and then 1 unit to the right to get to M. So I can do the same thing. Down 1, 2, 3 units to the right, and that is where our endpoint K should be. And then double checking to make sure we have the correct coordinates. 1, 2, 3 to the right, and 1, 2 units down. Alrighty, take a moment, pause the video here, and see if you can give this one a try on your own. Alrighty, so go ahead and double check over your answers. Again, the one thing you want to watch out for is which variable we are solving for. Again, I opted to use x2 and y2 as our unknown, and that's what we were solving for. And make sure that you substitute in for xm and ym because we already know what those midpoint coordinates are. All right, so that is it for your notes for 1.3 midpoint formula. Thank you very much for watching.